Alright, hello everyone, welcome to my YouTube channel. In this video we're going to look at the remainder theorem. Recall that we've been talking about polynomials and we recently discussed the division of polynomials, and so we saw that a polynomial can be divided by another polynomial so far as the divisor has a lesser degree than what is being divided. Okay, now we also saw that in some of the division examples that some of the divisors were factors. That means they divided without any remainder, whereas in some of the divisions we got remainders. Okay, and so now we are trying to see, is it possible to find what the remainder of a particular division will be even without doing that division? That's what remainder theorem is all about. And so we discovered that recall that if you have, let's use an ordinary number, let's say 7. If you divide 7 by 2, this is going to give you 3 remainder 1. And I can actually write this in some other way. This means that my 7 is actually equal to 3, or let me say 2 times 3 plus that remainder. So this is what you divided, is equal to the divisor times the quotient plus the remainder, and of course this holds. Okay, so and it is from this concept that we're able to find this statement. And meanwhile, what was the statement of remainder theorem? It says that if a polynomial p of x is divided by a linear polynomial, say x minus a, then the remainder of that polynomial is just p of a, meaning just substitute whatever you have here as the linear polynomial x minus a, you should equate it to 0 and get the value of x, and then substitute this into that polynomial as your x. Whatever you get will give you the remainder. And so we're saying that how did we get this? So from what I just stated here, it means that if you divide p of x by x minus a, let's assume it gave you a quotient which will be a function of x also, then remainder, let's call the remainder r. So from what I just stated here, the implication of this is that p of x is actually equal to the divisor, which is x minus a, just as we did here, 2 times the quotient, which is 3, and in this case is q, let me not use that times, which is q into x, and then plus the remainder, just like we did here, and our remainder in this case is r. So please always remember this relationship is going to be very important, because it is this relationship that helped us prove that this statement is true, and it will also be very important when we start talking about factor theorem. Okay, so from here you can see that if you decide to call your x to be equal to a, what it means that you are going to have p of a is equal to, if I put a here now, I will have a minus a times q x, then plus r. Now, but a minus a is 0, and so everything here will turn to 0, and so you will just have r, which is your remainder, to be equal to p of a. And that's how this relationship was gotten. So the remainder, whenever a polynomial is divided by a linear polynomial, is equal to the substitution of this. Let's look at some examples. Okay, so here we have examples here. It says that without actual division, find the remainder of this. And of course, even without telling you without actual division, you should know that that will be faster for us. Okay, so let's begin. Example 1, we want to find the remainder when this polynomial is divided by this, and so we have x cubed, and we are dividing it by x minus 3, and so just equate this to 0. So this means that your x is equal to 3, and so it means that our remainder is going to be 3 raised to power 3. So we are substituting x for 3. And so this is 3 raised to power 2 plus 11 times 3 minus 5. And of course, this is 27. And this is 9 times 7, which is 63, plus 33 minus 5. And this is going to give us, of course, this minus 30 minus 3, and we will have minus 8. Okay, so if you do this subtraction carefully on your own, you will definitely, if you do this division without using this approach, you will definitely get this negative 8. And then let's take this example. I will allow you to do the second one as an exercise. For example 2, we have that our polynomial, that is p of x, is equal to 5x minus 6x squared minus 7 plus px cubed. And in this case, we are looking for the remainder, where the divisor is 2x minus 3. So if you equate this to 0, you are going to have that x is simply equal to 3 all over 2. Okay, so here now, this now means that our remainder, which will be p of 3 over 2, is now going to be 5 times 3 over 2 minus 6 times 3 over 2 squared minus 7 plus 2 3 over 2 all cubed. Okay, and so if we come over to this side, let's try to finish it here. So what you're going to have now here is that our remainder r is going to be equal to, okay, if you open this bracket, you will have 15 over 2. And then if you open this one, this will give us 9 all over 4. And so we'll have 6 times 9 is 54 all over 4. Then minus 7, we can call this over 1. And then this is 27 all over 8. That's 3 raised to power 3 is 27 all over 8. And 27 times 2 is also 54 all over 8 here. And then we can try to reduce. And if we do that, we're going to have 2 here is 27, 2 here is 2, 2 here is 27, 2 here is 4. Okay, so if we take LCM now, our LCM is going to be 4. This is 2 times 15 is 30. This is also 2 times 27 is 54. And this is 1 divided 4 is 4 times 7 is 28, plus 4 here is 1, and then we have 27. And this is going to give us okay, so that's going to give us, if we come over here, you are going to have that is equal to, if you sum this is minus 24, minus 24, and then this one plus this is minus 1. Minus 24 minus 1 is minus 25 all over 4. And that is our remainder for example 2. So try to look up for the value of the remainder in example. This for example 3. Try to find the value for example 2. Okay, so that's all about the remainder theorem, and we are going to look out for other applications in our next video, applications or problems that you can solve using the notion of remainder theorem. Kindly subscribe to our YouTube channel, and we'll see you in our next video. Bye.